Gas appliances are not considered part of the general lighting load in electrical calculations. Since the appliances are 120-volt heat pumps, they are included in the general-purpose receptacle circuits. This means the electrical demand contributes to the overall load calculation for the general receptacle circuit, not the lighting circuits. To accurately include the 120-volt heat pumps in your electrical load calculations, you'll need to follow a few steps. Firstly, determine the total number of general-purpose receptacle outlets on each circuit. Secondly, calculate the load for the general-purpose receptacle circuits. The National Electrical Code, or NEC, typically requires a minimum load of 180 volt-amps per receptacle outlet. Thirdly, add the load of the 120-volt heat pumps to the load of the general-purpose receptacle outlets. The heat pump's voltage and amperage requirements will determine its load. For instance, if a heat pump draws 1 amp at 120 volts, its load is 120 volt-amps. Fourthly, calculate the total load for each general-purpose receptacle circuit by summing the volt-amps for all receptacles and any additional appliances like the heat pumps on that circuit. Then, apply any applicable demand factors according to the NEC. Demand factors allow for a reduction in the calculated load based on the assumption that not all loads will be operating simultaneously at their maximum. The NEC provides tables outlining these demand factors for various types of occupancies and loads. For example, NEC Table 220.42 provides demand factors for general lighting loads in dwelling units. While this specific table doesn't apply directly to receptacle circuits with heat pumps, it demonstrates the principle of applying demand factors. Locate the appropriate NEC table for general receptacle circuits in your specific application. These tables are located in NEC Article 220. Multiply the total load of the general-purpose receptacle circuits, including the heat pumps, by the applicable demand factor to determine the design load. The design load is the load used for sizing circuit breakers, conductors, and other electrical equipment. Ensure the circuit breaker and conductors are adequately sized to handle the design load. Circuit breakers must be sized to protect the conductors from overcurrent. Conductor ampacity must be sufficient to carry the design load without exceeding the conductor's temperature rating. The NEC provides tables for determining conductor ampacity based on conductor size, insulation type, and installation conditions. Refer to NEC Table 310.13b16 for conductor ampacities. Consult a qualified electrician for assistance in selecting the correct circuit breaker and conductor sizes. Also, ensure the wiring meets all applicable local electrical codes and regulations. Local codes may have more stringent requirements than the NEC. Ignoring local codes can result in violations and safety hazards. Consider the location of the heat pumps when planning the receptacle circuits. The NEC may require dedicated circuits for certain appliances based on their load and usage characteristics. Dedicated circuits prevent overloading of general-purpose circuits and ensure reliable operation of the appliances. Check with your local building inspector for specific requirements regarding dedicated circuits. In summary, when including 120-volt heat pumps in your electrical load calculations, firstly, treat them as part of the general-purpose receptacle circuits. Secondly, calculate their individual loads in volt-amps based on their voltage and amperage ratings. Thirdly, add their loads to the total load of the general-purpose receptacle circuit. Fourthly, apply any applicable demand factors. Fifthly, ensure the circuit breakers and conductors are properly sized to handle the design load. And sixthly, comply with all applicable electrical codes and regulations. Remember that electrical work can be dangerous, and it's always best to consult with a qualified electrician for assistance with any electrical projects. Proper planning and adherence to electrical codes are essential for ensuring the safety and reliability of your electrical system. By following these steps, the 120-volt heat pumps will be correctly accounted for in the electrical load calculations, ensuring the electrical system is adequately sized and safe. Moreover, for a more comprehensive understanding of electrical load calculations, consider consulting the National Electrical Code, or NEC, handbook. The NEC handbook provides detailed explanations and examples of load calculation methods. It includes information on general lighting loads, receptacle loads, appliance loads, and other types of electrical loads. The NEC Handbook can be a valuable resource for electricians, engineers, and anyone involved in electrical design and installation. In addition to the NEC Handbook, various online resources and training courses offer guidance on electrical load calculations. These resources can help you stay up to date on the latest code requirements and best practices. It is important to note that electrical codes and regulations may vary depending on your location. Always consult with your local building department or electrical inspector to ensure compliance with all applicable codes. Ignoring local codes can result in fines, delays, and safety hazards. Furthermore, consider the potential for future expansion of the electrical system when performing load calculations. It is generally advisable to provide some extra capacity to accommodate future loads. This can help avoid the need for costly upgrades later on. The amount of extra capacity to provide will depend on the specific application and anticipated future needs. Consult with a qualified electrician or engineer to determine the appropriate level of spare capacity. Remember that electrical load calculations are an essential part of electrical design and installation. Accurate load calculations ensure that the electrical system is adequately sized to handle the intended loads, preventing overloads, voltage drops, and other electrical problems. By carefully considering all applicable factors and following the steps outlined above, you can ensure the safety and reliability of your electrical system. When dealing with heat pumps, remember they may have different operating modes such as heating and cooling. Each mode might have different current draws, so it's important to consider the highest current draw when calculating the load. The nameplate of the heat pump should provide the necessary information about voltage, amperage, and wattage for each operating mode. Be sure to use the maximum values for accurate load calculations. Furthermore, some heat pumps have auxiliary heating elements that can significantly increase the electrical load. These elements typically come into play during extremely cold weather to supplement the heat pump's primary heating function. If the heat pump has auxiliary heating elements, be sure to include their load in the electrical calculations. The nameplate of the heat pump should indicate the wattage of the auxiliary heating elements. In addition to the load calculations, it's crucial to consider the voltage drop in the electrical circuit. Voltage drop occurs when the voltage at the load is lower than the voltage of the source due to the resistance of the conductors. Excessive voltage drop can cause appliances to malfunction and can also lead to overheating of the conductors. The NEC provides guidelines for maximum allowable voltage drop in branch circuits and feeders. To minimize voltage drop, use conductors that are large enough to carry the load and keep the circuit length as short as possible. Also, consider using conductors with low resistance, such as copper conductors. In summary, when including 120-volt heat pumps in your electrical load calculations, firstly, remember to treat them as part of the general-purpose receptacle circuits. Secondly, determine the maximum current draw of the heat pump, including any auxiliary heating elements. Thirdly, add the heat pump load to the total load of the general-purpose receptacle circuit. Fourthly, apply any applicable demand factors. Fifthly, ensure the circuit breakers and conductors are properly sized to handle the design load. And sixthly, verify that the voltage drop is within acceptable limits. Finally, comply with all applicable electrical codes and regulations. Keep in mind that electrical work can be dangerous, and it's always best to consult with a qualified electrician for assistance with any electrical projects. Proper planning and adherence to electrical codes are essential for ensuring the safety and reliability of your electrical system. Consider the impact of power factor on the electrical load calculations for heat pumps. Power factor is a measure of how effectively electrical power is being used. A low power factor can result in increased current draw or reduced efficiency. Some heat pumps have power factor correction capacitors to improve their power factor. If the heat pump has power factor correction, the nameplate should indicate the power factor. If the power factor is less than 1, you'll need to consider it when calculating the apparent power, which is the product of voltage and current. The true power, which is the actual power consumed by the heat pump, is the product of the apparent power and the power factor. When sizing electrical equipment, it's important to consider the apparent power, not just the true power. Moreover, consider the harmonic content of the current drawn by the heat pump. Harmonics are distortions in the sinusoidal waveform of the current. High harmonic content can cause overheating of electrical equipment and can also interfere with the operation of other electronic devices. Some heat pumps have harmonic filters to reduce their harmonic content. If the heat pump has harmonic filters, the manufacturer's specifications should indicate the level of harmonic distortion. If the harmonic content is high, you may need to consider using special electrical equipment that is designed to handle harmonic currents. Remember to consider the ambient temperature when selecting conductors for the electrical circuit. The ampacity of a conductor decreases as the ambient temperature increases. The NEC provides correction factors for conductor ampacity based on ambient temperature. Refer to NEC Table 310.15b2 for ambient temperature correction factors. Choose conductors that are rated for the highest expected ambient temperature in the location where they will be installed. Furthermore, consider the dirting factors for conductors that are installed in close proximity to each other. When multiple conductors are installed in a raceway or cable, their ampacity must be derated to account for the heat generated by the conductors. The NEC provides dirting factors for conductors based on the number of conductors in the raceway or cable. Refer to NEC Table 310.15b3 for conductor dirting factors. Choose conductors that are large enough to carry the load after applying all applicable dirting factors. Also, consider the type of overcurrent protection device that will be used to protect the electrical circuit. Overcurrent protection devices, such as circuit breakers and fuses, are designed to interrupt the flow of current in the event of an overload or short circuit. The NEC provides guidelines for selecting the appropriate overcurrent protection device for a given circuit. The overcurrent protection device must be rated to protect the conductors from overcurrent and must also be compatible with the type of load being served. In summary, when including 120-volt heat pumps in electrical load calculations, firstly, take into account the power factor and harmonic content of the current drawn by the heat pump. Secondly, consider the ambient temperature and dirting factors for conductors. Thirdly, select the appropriate overcurrent protection device for the circuit. Fourthly, ensure that all electrical equipment is properly grounded to prevent electrical shock hazards. Finally, comply with all applicable electrical codes and regulations. Always consult with a qualified electrician for assistance with any electrical projects. Proper planning and adherence to electrical codes are essential for ensuring the safety and reliability of the electrical system.